Chapter 7 is all about exponents. Section 1 is about zero and negative exponents. So we've learned about exponents before, sort of. We've never really learned about zero exponents or negative exponents. They're both more like concepts that you need to just understand. And once you understand them, you can work with them fairly easily. But you got to understand them first. So what we're going to do is look at this table and simplify things. And see if we can come up with a couple of rules. Before I do that, I want to remember what exponents mean. So like if I have 2 to the 4th power, what is 2 to the 4th power? It's not 2 times 4. If I wanted 2 times 4, I just write 2 times 4. It's 2 times itself 4 times. So 2 to the 4th is 2 times 2 times 2 times 2, which is what? 2 times 4 is 8. 2 times 2 times 2 times 2 is 16. This is not 2 times 4. This is 2 times itself 4 times, which means 2 times 2 times 2 times 2. And to do that, you go 2 times 2, which is 4, and then 4 times 2, which is 8, and then 8 times 2, which is 16. Or you can break this into parts, and this is how a lot of people who get really good at exponents will do this math in their head. 2 times 2 is 4, 2 times 2 is 4, and then 4 times 4 is 16. Since this is all multiplication, I can multiply in any order that I want. I can go from left to right, I can go from right to left, I can break it into groups, and then multiply the groups together, which is how I do it in my head, quickly. All right? So you can go 2 times 2, 2 times 2, and then multiply those two together to get your 16. Let's see, there's probably something else I should talk about. What would 10 times 10 times 10 times 10 be simplified down to? Yeah, that's 10 times itself 4 times. So that simplifies to 10 to the 4th power. It does not say 10 times 4. 10 times 4 is 40. But 10 times 10 times 10 times 10 is the same as 10 times 10, which is 100. 100 times 10, which is 1,000. 1,000 times 10, which is 10,000. Big difference between 10,000 and 40, right? So you need to understand what these exponents are actually telling you. It's repeated multiplication. Just like multiplication is repeated addition. And actually, I can really blow your minds here and tell you that if exponents are repeated multiplication, and multiplication is just repeated addition, and subtraction is just addition of the opposite, and division is just the reciprocal of multiplication, then really all we have here is one operation that we work with always and forever in mathematics, and that's addition. If you know how to add, you can do math. Because everything else is just addition in different ways. So in a long, roundabout way, what you're doing here is actually adding. Ignore all that. You don't need to know that. You need to know that exponents are repeated multiplication. So let's simplify each column of the table. Notice what we have here, 2 to the x power and 10 to the x power. It's not a coincidence that I chose 2 to the 4th and 10 to the 4th here. All right. So in this left column, we have 2 to the 4th power, which is what? Yeah, it's 16. What's 2 to the 3rd power? It's 8, not 6. 2 times 2 times 2 is 8. What about 2 to the 2nd power? Is 4. That's not 2 times 2 because you see a 2 and a 2 here. It's 2 times 2 because this says take 2 and multiply it times itself twice. Always think of it that way with your exponents. What about 2 to the 1st power? It's just 2. We're not actually multiplying 2 times itself. It's just 2. Well, then the question is, what is 2 to the 0 power? It is 1. Somebody already learned that one, I guess. It's 1. How is it 1? Is a great question. How is it 1? Why is it 1? Do you know why it's 1? Nobody knows why it's 1? Should I just call it 1 and say that's good? Just call it 1? We don't know why, so just call it 1? No. What is something divided by itself? Like if I have 5 divided by 5. 1. Tommy divided by Tommy is 1, right? So anything divided by itself is just 1. Yeah? Okay. In a little while, we'll learn why this is actually 2 to the 0 power is equal to 1. What would 10 to the 0 power be? It's also 1. It turns out that anything to the 0 power is 1. And I'll show you how in a little while using division. 2 to the negative first power is what? No. Did you have a guess? Nope. Has nothing to do with negative signs, actually. It's 1/2. Now you're done? What about 2 to the negative second power? Yeah, it is 1/4. Good. So using that logic, what would 2 to the negative third power be? 1/8. What's happening? It's not having. It's putting 1 over each time. What's 10 to the fourth? 10,000. And what's 10 to the third? 1,000. And what's 10 to the second? 100. Do we have another word for 10 to the second power? 10 what? Squared. Good. What about to the third power? Do we know that one? Cubed. Good. So these two have special words that we'll use over and over, and you need to know that. What about 10 to the first power? It's just 10. What's happening each time from here to here to here to here? What's happening to that number? It's being what? I'm not subtracting. How would I go from 10,000 to 1,000? Divide by 10. How would I go from 1,000 to 100? Divide by 10. How would I go from 10 to 1? Divide by 10. So the pattern here to go from here to here to here to here to here is divide by 10 each time. What if I take 1 and I divide it by 10? I get 1/10, which is why 10 to the negative first power is 1/10. What if I divide by 10 again? 1/100th. And now let's go back to the other column. What's happening each time with my answers here? 16, 8, 4, 2. What's happening to go from each? Divide by 2. So 16 divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. And we just continue. And these exponents would continue to be decreasing. Same thing over here. These exponents continue to be decreasing. And each time we go on our table, we're just dividing by this number right here, 2. Or over here, we're dividing by that number as we go. And hopefully that kind of, if you think about it, should make sense because exponents are just repeated multiplication. So if I have 2 to the third, then what I have is 2 times 2 times 2. I don't have this extra times 2. How did I get rid of an extra times 2? I divided it. Okay, so to go from here to here, that extra times 2 disappeared, and I wound up with just 2 times 2 times 2. 2 to the second power was 2 times 2. 2 to the first power was just 2. Each time I'm kind of like dividing these by 2 to wind up with just that number. Okay? So that's your introduction to working with exponents. There's better ways to think about exponents, though, and I'll teach you those here as the chapter goes on. Zeros as an exponent for every non-zero number a. So that just means if I have some number to a power of 0, something to the 0 power is always 1. So that's something you just got to remember, I guess. Anything to the 0 power is 1. That table that you're sitting at to the 0 power would be 1. Okay? For example, 4 to the 0 power is 1. Negative 3 to the 0 power is 1. And notice how they use parentheses around that negative 3. We're going to have to talk about when to use and when not to use parentheses around negative numbers. 5.14 to the 0 power is 1. Pi to the 0 power is 1. Anything to the 0 power is 1. Automatically. Except for 0? Yeah. That's every non-zero number. If you have 0 to the 0 power, that's actually undefined. Just like slope, if you have division by 0, you wind up with an undefined slope. You can't have 0 to a 0 power. Okay, for negative exponents, this is your other rule for this section. For every non-zero number a, so as long as it's anything but 0, and something to that power with a negative sign in the exponent, that has nothing to do with the sign of the answer. The negative exponent just means go 1 over this guy, and then what happened to the exponent? It turned positive. So that's your rule for negative exponents. If you have a negative exponent, it simply means put 1 over that thing and then make the exponent positive. It's something you have to remember. Get used to working with it. It's no problem. In the beginning, though, it's kind of tricky. So if I have 7 to the negative third power, that does not mean that the 7 is negative. It means that the negative third power tells me to go 1 over 7 to the positive third power. Once I have moved it under that 1, that exponent is now positive. You'll learn why in a little while. For right now, you need to know that that is a rule. If I have negative 5 to the negative second power, notice how they have parentheses around that. That means I take 1 over this thing, negative 5, in parentheses, and then that negative 2 becomes what? Positive 2. Once I've done that rule, then the exponent becomes positive again. When we're using exponents, the number under the exponent is called the base. Little vocab word there. You'll hear me say a base of 7, or a base of negative 5, or a base of 4, or a base of negative 3, or a base of a. That thing under the exponent is called the base. Any number or any variable can be a base. With any number as an exponent. Actually, when you get to Algebra 2 and beyond, actually in this chapter even, you can have a variable in the exponent as well, and we will in this chapter. Except for one thing. The number 0 can't have an exponent of 0. That's undefined. 0 to the 0 power is undefined. That's something that you have to remember. If you have a calculator sitting in front of you, type in 0 to the 0 power. You would type 0, and then the exponent button looks like a little carrot, and then 0. And then you get equals undef. I know it looks like a little face or something, right? It's undefined. It doesn't work. So 0 to the 0 power is the only one that we can't do. All right, what is 3 to the 0 power? Yeah, it's 1. What about 2 to the 0 power? It's 1. What about 1 to the 0 power? Is 1. What about 0 to the 0 power? Undefined. The number 0 can't have a negative exponent either. That's undefined too. How come? What about it? You're so close. Yes, you can't have a 0 in the denominator. Let me give you an example of that. If you had 0 to the negative fourth power, let's say, that negative exponent tells me that I need to go 1 over what? 0 to the fourth power. Well, what is 0 to the fourth power? Yeah, that says 0 times itself 4 times. 0 times 0 times 0 times 0, which is just 0. So this becomes 1 divided by 0. What's wrong with that? Yeah, you can never divide by 0. If you try to do that, the whole world would probably explode. You can't do it. Ever. Not even in calculus can you do that. Don't do it. I don't want to explode. All right, so we'll just leave it at that. We can't do that. So therefore, we can't have 0 with a negative exponent on it either. All right? Good job. So now that we know those two rules, and there are a lot more rules that we're going to have to learn and memorize and know how to work with, but now that we know these two rules, negative exponents and 0 exponents, we can start to simplify problems a little bit. So this first one says 9 to the negative second power. Well, what does the problem tell me I need to do? Take out the negative exponent first. So that makes 1 over 9 to the positive second power, 1 over 9 squared. Well, what is 9 squared? It's 81. So this becomes 1 over 81, and that's your answer. You don't have an answer until you do not have negative exponents anymore. You always simplify your numbers as much as you can. You get rid of your negative exponents and take out your 0 exponents as well. If you're typing it into your calculator, you shouldn't be. What does this one tell me to do? Do I got to go 1 over because that's a negative sign right there? No, that's just a negative number. The exponent says to the 0 power, and anything to the 0 power is 1. So that's your answer. Try to avoid using a calculator. If you avoid using a calculator, you will learn these rules way faster than the people who are relying on their calculator. And then it's going to be a bummer when I give you a problem that looks like this. X to the negative second power. Calculator doesn't know how to do that. So you got to know how to do that, which means you got to know these rules. So don't touch your calculator except to check. How about 4 to the negative third power? What do? Good. 1 over 4 to the third power. 4 times 4 times 4 is 64. So this becomes 1 over 64. Did you do that without a calculator? You checked it. How about the next 3? Go ahead and do those. Do not touch your calculator. Okay, let me get rid of my calculator here. And what do we get for the first one? Yeah, anything to the 0 power is 1. What about the second one? 1/9 is correct. The negative second power tells me 1 over 3 to the positive second power. But 3 to the positive second power, 3 times 3 is 9. So we get 1/9. That's our answer. Now this last one is probably the trickiest one we've done so far. What does that tell me to do? The negative exponent here tells me 1 over, in parentheses, negative 4 squared. You got to pay attention to those parentheses. Now what? Negative 4 squared. We can do that. 1 over negative 4 times negative 4, which is positive 16. So 1/16. But a positive 1/16 is the answer. Now before we go on, I want to point something out to you. I've been saying these parentheses are important, and they are. We just found out that if we square negative 4, we get positive 16, right? Type negative 4 squared into your calculator. The negative sign has to be the negative sign, not the minus sign. So that's this guy here. And then 4. And then to the second power. Press enter. Why did it give me negative 16? Because I didn't use parentheses. Why did it carry that negative in there? How come if I have negative 4 squared, which we know is positive 16, how come the calculator gave me negative 16? Is it garbage? Calculator's junk? The reason is the calculator sees what you wrote as this. Negative 1 times 4 squared. And now order of operations tells me I have to do 4 squared first and then multiply by negative 1. So that becomes negative 1 times 16 which is negative 16, which is not what we wanted at all. So what we need to do is type in parentheses negative 4 squared. If we do that, hopefully that will fix our problem. So I type in parentheses and then negative 4, close the parentheses, and then to the second power. Hit enter, and now I have positive 16. So if you want a negative number raised to an exponent, you need to include parentheses around them. Otherwise, the calculator has been programmed to see this, which is not what you want. So it's just a matter of understanding what the calculator sees. Once you have that, then you should be good. Okay? 9 through 19, 10, what is that? 10? No, 6. It's only odd problems, so it's like 6 problems. Check your answers and make sure that you're doing them correctly. Do not use the calculator unless you absolutely have to. Please. Make sure you learn these rules correctly. The next thing we're learning is that there's a special way that you should treat your negative exponents, especially if you're working with variables, which we will be doing in this chapter. It's not always just going to be numbers. You have to know how to work with numbers. You got to know how to work with the variables as well. So, when simplifying, the exponent goes with only its own base. Your answer can't have any negative exponents in it, and I've kind of already mentioned that. But we don't have an official answer until there are no negative exponents remaining. Remember, the negative exponent has nothing to do with the sign of the number. It just means take the reciprocal. If you put 1 over something, that's the reciprocal. So the way that I do these is I put them over 1. I make a fraction. And then if I have a negative exponent, that negative exponent thing moves. If it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. So in this case, does this 5 have a negative exponent on it? No. Does it have an exponent at all? Actually, it does. If we don't write an exponent, we assume that it's a 1. Kind of like if we don't write a number in front of a variable, we assume it's a 1. So this is actually 5 to the first power. That's not a negative exponent, so it stays where it is in the numerator. Then we have this a to the third. Is that a negative exponent? Nope. So it stays where it is. The a to the third stays in the numerator. What about this b to the negative second? It's going to go to the denominator. B to the positive second is what you will write, because once you move it, the exponent becomes positive. So what's really happening here is this is just off to the side. This is the correct answer right here. Off to the side, this became 5 times a to the third times b to the negative second. Right? It's all just multiplication. So then I have 5 times a to the third times 1 over b squared. When I multiply fractions, I multiply across. So I put 5 over 1, a to the third over 1, and then I just multiply straight across. 5 times a to the third times 1 is just 5a to the third. 1 times b squared is b squared, like that. So that's the math that's going on behind the shortcut that I'm trying to show you. Just put your division bar on there and then move things to the correct location and you're done. So for this second one, 1 over x to the negative fifth power, I'm going to put my division bar on there. The 1's in the right spot, but the x to the negative fifth power is not. It is in the denominator right now, so it's going to move to the numerator. What's left in the denominator? A 1. How come it's a 1? Because mathematically, what was the number in front of this x right here? A 1. And what was the exponent on that 1? What was the exponent that I didn't write for the 1 that I didn't write? A 1. And since that's a 1 to the 1, it's in the correct spot, so it stays here. This one was in the wrong spot, so it moves up. Basically, if you see a negative exponent in the numerator, it goes to the denominator. If you see a negative exponent in the denominator, it goes to the numerator. You're never going to have nothing when you move something. There's always going to be a 1 left over. How about x to the negative 9th power? One over x to the 9th is correct. What about 1 over n to the negative 3rd power? This guy, next row. What do we get? N to the 3rd over 1, that's correct. Notice that n to the 3rd over 1 is the same as n to the 3rd. And also, a negative exponent tells me to take the reciprocal, and the reciprocal of this is 1 on the bottom, n to the 3rd on the top. What about 4c to the 3rd b? Yeah, there's no negative exponents there. There's nothing to do, so that's already the answer. How about 2 over a to the negative 3rd? Does the 2 need to move? No, it stays. Does the a to the negative 3rd need to move? Yes. So it was in the denominator. It moves to the numerator, and I write what? A to the 3rd power. Technically it would be over 1, but anything divided by 1 is itself. So I don't even have to write the over 1 part. That's the answer. All right, bottom row. These 3 problems are getting a little bit more complicated. Remember what I suggested that you do in this very first problem. Draw your division bar. Place things in the correct spot. So, is n to the negative 5th power in the correct spot? No. Where should it go? To the denominator. Is m squared in the correct spot? Yes. So, since m squared is in the right spot, I'm going to write m squared, and n to the negative 5th becomes n to the positive 5th in the denominator. What's in the numerator? 1. Good. How come it's 1? We're not assuming that it's 1. We know that it's 1. Why do we know that it's 1? Because the number in front of the n was 1. We moved the n to the negative 5th, so we were just left with that 1. That's not the same thing as assuming. It's true. Okay, next one. What should we do? Draw your division bar. That's a great place to start. And then just start putting things in the right spot. So, where does that 3 go? It stays put. That's a 3 to the positive 1 power. So that 3 stays in the numerator. What about the a? Goes to the denominator. I'm going to write a squared. And then what about that b to the 3rd? It stays, and I write b to the 3rd. Do I have any negative exponents still hanging out? Nope. So that's my correct answer. See if you can do that last one on your own. Okay, what should we do? Division bar, good. And then, yeah, we got the y down here with a negative exponent, so that's got to move to the top and become y squared. But this x to the negative 3rd goes to the bottom and becomes just x cubed. And that's the answer. You're done. So draw the division bar and then place everything where it should go. Remember, if you see a number with no exponent on it, like if I just give you a 3, is there an exponent on that 3? Yes, what is it? It's a 1. It's not 0. If it was 0, then you would see a 0. And if it was 3 to the 0, then actually your answer there would be 1. And just to review, what's 2 to the 4th power? 16. Because that's 2 times 2 times 2 times 2. All right? So your answers, if I had, let's say I had a 4 squared here on top of that. So I had 4 squared x to the negative 3rd. Where does that 4 squared belong over here? On top. But 4 squared is 4 times 4, which is 16. So that would be my answer then, okay? The numbers, you can evaluate the exponent, but the letters you can't. You got to leave them as just squared or cubed or whatever the exponent is. Okay? All right. 21 through 35, that's like another, I don't know, 7 problems or something. Go for it.